Okay, let's unpack this. Welcome back to another deep dive. This is where we take a big pile of information and really boil it down to those key bits of knowledge you need to be genuinely well informed. Today, we're diving into something fundamental for anyone involved in academic work. The research paper. If you're looking to understand things quickly, really get a grasp not just on what's being said in scholarly discussions, but how it's being said, well, this deep dive is kind of your shortcut. And here's something that might really change how you look at these papers. Writing one isn't just about listing facts you found, not at all. It's actually about building a persuasive argument. You're in this highly competitive space, trying to convince people. Think of it like a written debate, really formal, using evidence, showing your methods, interpreting things. It's a big display of your thinking, your grasp of the topic. So, our mission today, we're focusing on the foundations, drawing insights straight from Unit 7 of academic writing for graduate students. We'll look at different kinds of publications because it's not all one thing, the overall structure, and then really get into the weeds with the methods and results sections. Crucial stuff.
Yeah, and what's really fascinating is exactly that point you just made. This idea that academic writing, especially the research paper, it's less about just dryly reporting stuff and much more about communicating strategically.
Hmm.
A lot of people see it as just transmitting information,
Yeah.
but it's really about positioning yourself, positioning your work within this larger scholarly conversation that's always going on.
Positioning. That's a good word for it.
Right. These papers, they're essentially arguments, really sophisticated ones, designed not just to tell someone something, but to convince them, to shift their view a bit, and, hopefully to add something genuinely new and useful to what everyone in that field knows. So it's not just about ticking the box, getting published. It's about making sure people really get what you're saying, influencing the conversation in your field, building your own credibility. And honestly, even small things like how you structure a sentence or the specific words you choose can make a huge difference in how people receive your research. It's all about building that trust, showing you've mastered your stuff.
That idea of strategic communication, it really does shift things. Makes you think, if it's more than just reporting facts, what does that mean for all the different kinds of research out there? Because, like you said, when people hear research paper, they often picture, I don't know, a lab report, white coats, speakers.
Exactly, that image.
But the academic world is way more diverse than that, isn't it? I mean, even in science, you can't always run an experiment. Think about astrophysics. You can't exactly put a star in a test tube.
Yeah.
So how do they share knowledge?
Precisely. And that's the key. How knowledge gets made, how it gets checked, how it gets shared, it varies massively across different fields. So the kinds of publications you'll actually see, or maybe even write yourself, are much more varied than just that one lab report image. Empirical studies, sure, those based on experiments or direct observation, they're definitely a cornerstone, can't deny that. But they're not the only game in town, not by a long shot. For instance, you have review articles. These are, frankly, indispensable. They don't present brand new data from an experiment. Instead, they carefully pull together and critique the existing research on a specific topic. They give you the big picture, identify maybe where the gaps are, suggest new directions. Think of them as like an expert tour guide through a massive library of studies.
Okay, so they synthesize what's already known. Makes sense.
Then you've got theoretical papers. You see these a lot in fields like philosophy, economics, maybe some parts of physics. Their goal is to develop new theories or conceptual frameworks, new models. They often build on earlier ideas, but in a more abstract way, not necessarily through lab work. They're about exploring ideas, pushing boundaries, challenging assumptions, suggesting new ways to understand really complex stuff.
Right, more abstract, idea-driven.
And case studies, very common in medicine, psychology, business, social sciences, you name it. These give you a really deep, detailed look at one specific thing, maybe a particular patient, a specific company's strategy, a unique event. They provide rich, sort of qualitative insights, let you explore something in its messy, real-world context. And often, that detailed look can spark ideas for bigger studies later on.
Okay, so reviews, theoretical papers, case studies. Quite a range already.
And then we get to short communications, or sometimes they're called brief reports, technical notes. Different names, same idea. These are really interesting because they play this unique role in getting information out quickly. They're concise. Yeah, typically maybe 3 to 6 printed pages. But don't let the length fool you. Increasingly, they follow that standard IMRD format. We'll talk about introduction, methods, results, discussion. And they almost always have an abstract. just like the longer papers.
IMRD, even for short ones.
Yeah.
Interesting.
And here's something really powerful, especially if you're just starting out on your research path.
Yeah.
These short communications, they are often the very first things that junior researchers manage to publish. Think about how daunting it feels to write that first huge research paper. It's a massive undertaking.
Absolutely terrifying, yeah.
Yeah, right. So what if there was like a stepping stone, a way to share something new and important, but without that enormous scope and time commitment? That's exactly what short communications offer. They're a more accessible way into the whole scholarly conversation, lets new scholars share novel but, focused findings, helps them build their publication list, build their confidence. It's a really important entry point.
That makes a lot of sense, a way to get your feet wet.
Exactly. And within this category, there's a really specialized type that you see a lot in fields where people do fieldwork reports. We're talking biology, archaeology, geology, linguistics, folklore, local history, architecture, even ethnomusicology. Lots of fields. Their main job, to report something rare or unusual that was found out in the wild, so to speak. Could be, a weird rock formation someone stumbled upon, or an odd dialect usage in some remote village, or maybe a plant or animal observed somewhere it wasn't expected.
So documenting unexpected discoveries on the ground.
Pretty much. And this tradition, it actually goes way back, like 17th century back, to when scientific journals first started. They were originally set up partly for naturalists to share exactly these kinds of observations. It's all about documented, reportable discoveries that add a piece to the puzzle of understanding the world.
A reportable discovery sounds like you'd need a trained eye to even know it's reportable. It's not just I saw a bird. Can you give us an example, something concrete from Unit 7 that shows what makes a specific fieldwork observation worth publishing?
Definitely. A great example is a short communication about finding a badger. It's titled Occurrence of a Badger in Pictured Rocks National Lakeshore, Michigan, published back in 2007 by Belant, Wolford, and Kainalainen. Now, on the surface, it's about one badger, seems super specific, but it perfectly shows the genre and the careful science involved. So badgers, right?
Right.
They're known across the western U.S., Great Plains, even into Ohio. In Michigan specifically, they'd been confirmed in basically all counties, including the Upper Peninsula. And here's the kicker, the thing that makes it reportable.
There's the but.
There's a but. Despite being pretty widespread, they had not been officially confirmed in this one specific area. The Pictured Rocks National Lakeshore, or PRNL, that's up in Alger County in the UP. So the significance wasn't just a badger, it was a badger here, where we didn't have solid proofs they existed before.
Okay, so the location was the key, the lack of prior confirmation. How did they actually find it then? Was it like a big badger hunt?
Not at all. Which makes it even more interesting, actually. The discovery was completely incidental, total accident. They were doing this study on American marten, a totally different animal, and on September 16, 2004, whips, a badger wanders into one of their cage traps right next to the PRNL boundary.
Serendipity strikes again in science.
Doesn't it just? So once they had it, the researchers, who were obviously trained wildlife specialists, they followed careful procedure. They immobilized it safely using telazol, monitored its vital signs to make sure it was okay, standard stuff. Then they fitted it with a radio transmitter for tracking and took a whole bunch of standard body measurements.
And what did those measurements tell them? What were the crucial bits of data that turned this accidental catch into, actual science?
They got really precise data. Even without pulling a tooth, which is the surest way to age some animals, the measurements strongly suggested it was a yearling, about a year old. Things like body length, 64 centimeters, total length, 76 centimeters, skull length, 12 centimeters, skull width, 9 centimeters, weight about 6 kilograms. They also noted specific details. Teeth weren't damaged, no staining. Nipple size and color indicated it hadn't had young. These details paint a picture of the individual animal. But most importantly, using that radio transmitter, they got 6 location points through September 2004. And those points confirmed the badger was using habitat both inside PRNL and right next to it. So it wasn't just passing through briefly, it was actually living there, at least for that period.
Right, so the so what isn't just badger sighting, it's first confirmed scientifically documented occurrence in this specific national lakeshore. That is a big difference. What was the takeaway then?
Exactly. It wasn't just an anecdote, it was verified. The first confirmed occurrence in PRNL. And that matters for understanding the local ecosystem, maybe conservation plans for the park. And the direct result. In the paper, the authors concluded by basically calling for more systematic surveys to figure out how widespread badgers really are in and around the park, which shows you how even one single well-documented finding like this can spark broader research. It fills a tiny gap, But that gap might lead to bigger questions. It shows how a trained specialist, being rigorous, documenting carefully, and putting that observation in context, can turn a seemingly small discovery into a genuine contribution. And if you look closely at how that short paper is structured, it's actually pretty clever, even without having formal subheadings like methods or results. Those 5 paragraphs, they flow logically, kind of like a problem solution or general to specific pattern. Para 1, background sets up the problem, the unconfirmed presence. Para 2, capturing how data was collected, the methods bit. Para 3, the measurements, the aging clues. Para 4, where it went, the habitat, the results bit. Para 5, conclusion first, confirmation, recommendation for more study. It's tight, structured, clear. Even in just reporting a discovery, not testing a big hypothesis, the authors are structuring it to be convincing, credible, impactful. It's subtle, but effective.
That's a fantastic illustration. Really drives home how varied these publications can be, not just lab coats and test tubes. So, taking that broader view, what does this all mean for the, let's say, the typical longer research paper, the kind most people probably encounter more often? Moving beyond these short reports, what's the grand design? The blueprint for that standard paper?
Okay. For that typical empirical paper, the standard blueprint is almost always IMRD. Introduction, methods, results, and discussion. People often call it the hourglass shape, and honestly, it's a perfect analogy.
Hourglass. Okay, I can picture that.
Yeah, think about it. You start broad in the introduction. You set the general scene, the context for your topic. Then, whoosh, it narrows right down in the methods and results. You get super specific, focusing only on the nitty-gritty details of your particular study. What you did, what you found, and then it widens back out again in the discussion. You take your specific findings and connect them back to the bigger picture, the wider field, the broader implications. It's not just some random format someone made up. It's a narrative structure designed very deliberately to guide the reader logically through the whole research story. Why did you do it? How did you do it? What did you find? And, crucially, what does it all mean? It builds the argument piece by piece.
Okay, breaking it down like that really helps see the logic. Can we walk through each section's main job again, just to fix it in mind?
Absolutely. So the introduction, its main job is to give the rationale. Why does this research matter? It moves from the general topic area down to your specific question, or the problem you're addressing, or the hypothesis you're testing. Basically, it answers, why this topic? What do we already know? What's the gap your study is trying to fill? And maybe a secondary purpose, but still important. It needs to grab the reader's interest, make them want to read on. A dull intro kills a paper fast.
Hook the reader early. Got it. Then methods.
Methods?
Oh.
Simple purpose. Explain how you did the study. This needs to be super clear, super precise, enough detail so someone else could, in theory, replicate your work, or at least understand exactly what you did to get your results. Transparency is key here for credibility.
Makes sense. And results?
Results are. This is where you present your main findings. What did the study reveal? Ideally, this section presents the findings clearly, objectively, just the facts, ma'am, mostly. What did the data show?
Okay, the what. And finally, discussion.
Discussion, D. This is where you step back and interpret those results. You connect them back to the intro, back to the broader field. You explore the implications. What does it all mean? This is where you tackle that big so what question head on. You also usually discuss limitations of your study here and maybe suggest directions for future research. It's where you make your final case for the importance and meaning of your work.
IMRD. Intro. Methods. Results. Discussion. Seems straightforward, but powerful. Are there ever, variations on this theme?
Oh, definitely. While IMRD is the gold standard, especially in sciences and many social sciences, you do see variations. Sometimes, particularly maybe in qualitative research or certain humanities fields, authors might combine the results and discussion. If the findings are so closely tied to their interpretation, separating them might feel artificial or break the narrative flow. Or, if you have a really complex paper reporting on, say, 3 different but related experiments, you might see a cycle. Methods 1, results 1, discussion 1, then methods 2, results 2, discussion 2, and so on, followed by a general discussion at the end. But even with these variations, those core functions, setting the stage, explaining the process, presenting the findings, interpreting the meaning, they're always there in some form.
Right, the underlying logic holds. Now, you mentioned something earlier that really caught my ear, linguistic fingerprints for each section. That sounds subtle but important. What did you mean by that?
Yeah, it's this fascinating idea that each part of the IMRD structure tends to use language in slightly different ways. It has its own sort of grammatical signature. When researchers analyze huge numbers of academic papers, like in the studies referenced in our source material, these patterns jump out. And it's not just random style choices. These linguistic features act as subtle signals to the reader, telling them what kind of information to expect in that section, often without us even consciously noticing it. The language itself helps guide you.
Okay, I'm intrigued. Give me some examples, like what kind of fingerprints are we talking about?
Okay, let's take tenses, for example, a really clear one. You'll find the present tense used a lot in the introduction and the discussion. Why? Because these sections often talk about general truths. Climate change is a problem, current knowledge, research shows that, or the implications of your findings, this suggests. Things that are generally considered true now. But you'll see much less present tense in the methods and results sections.
Right, because those are describing what happened in the past.
Exactly. So the past tense is dominant in methods and results. You're recounting specific things that were done or were observed. The samples were heated, participants indicated. It's a factual report of completed actions and findings. Past tense does pop up in the intro and discussion, maybe when citing previous studies. Smith found that. But it really takes center stage in those middle sections. And the present perfect tense has been shown, have suggested. You see it sometimes in the intro discussion, maybe talking about established research areas, but it's pretty rare in methods results because those focus on completed past events, not things continuing to the present.
Tense shifts make sense. What about other fingerprints?
Passive voice. This is a big one and often debated. You find a lot more passive voice in methods and results sections. The samples were analyzed, participants were selected. Why? The traditional reason is it keeps the focus on the action or the process itself, not on the researcher. We analyze the samples. It makes it sound more objective, more impersonal, which is often valued in scientific reporting. The method is the star, not the person doing it. You see less passive voice in the intro and discussion, where the author's voice and argument might be more prominent.
Okay, passive voice for objectivity and methods results. What else?
Citations. Predictably, lots of citations in the introduction and discussion. That's where you're building your case on existing knowledge, showing how your work fits in, agreeing or disagreeing with others. You need to back that up. But very few citations usually appear in methods and results. Those sections are about your specific study, your procedures, your findings. Less need to reference others right there.
Right, focus is internal there.
And one more, hedges. These are words that sort of soften a claim like may, might suggest, seems, tends to. You see some hedging in the intro, maybe in results, when describing a trend, but they become much more common in the discussion. Why? Because in the discussion, you're interpreting, you're speculating, you're talking about implications that might not be 100% certain. So you hedge your bets, linguistically speaking. You signal caution. These findings might suggest. You definitely don't hedge much in the methods section. You need to be precise about what you did. So this whole pattern, it points to those intersections, methods, and results. Be more concrete, just the facts of what happened. While the outer sections, intro and discussion, are more conceptual, framing the research, interpreting it, connecting it outwards. It's a fundamental rhythm in these papers.
Concrete inside, conceptual outside, I like that. And seeing how the language itself signals that shift is really illuminating. It's like the paper has different modes of talking. Okay, let's dive even deeper then into the method section. People often see it as the dry part, maybe just a list of steps. But like you said, it's absolutely vital for credibility. This is where, the proof is in the pudding, methodologically speaking. How do you actually write a good one?
You're right, it's far from dry. It's the backbone of your study's trustworthiness. The goal is crystal clear. Explain exactly how you did it, with enough detail so another competent researcher could understand, evaluate, and, ideally, replicate your work. It's your scientific recipe book. Now, how it looks can vary. Disciplinary differences are real. The heading might be methods or materials and methods, or maybe the study or participants and procedures. Fields have their own conventions. And subsections are really common, breaking it down into logical parts, maybe materials, apparatus, participants, data collection, procedures, statistical analysis, whatever makes sense for that study.
So the structure can vary. What about how much detail to include? Is more always better?
Not necessarily. This is where we need the Goldilocks principle. Not too much, not too little, just right. A good rule of thumb is only include the steps or details that, if you left them out, someone couldn't replicate the study or wouldn't understand how you got your results. You don't need to explain how to turn on the computer, or describe every single click if you use standard software. Over-explaining can actually bury the important stuff. If you used a standard publish method, you often just need to cite the original source. Then, crucially, you must describe any changes or modifications you made to that standard method. That's vital. The goal is clarity and completeness regarding the essential steps that influence the outcome.
Just right. Not too much, not too little. Can you give an example of that just right level? Maybe from that study about buying dodgy goods you mentioned earlier?
Sure, the Casola et al. Study on why people buy stolen or counterfeit goods is a good case. Their method involved giving people a questionnaire with different scenarios. They explained clearly that they varied the implied gender in the scenarios. That's a key detail. They mentioned randomizing the order. The scenarios were presented another key detail to control for bias. They noted they included demographic questions. That level of detail, according to our source material, was seen as sufficient. It tells you the core design. Questionnaire, scenarios, gender variation, randomization, demographics. Enough for someone else to understand the setup and maybe adapt it. They didn't need to include the exact wording of every scenario or list every single demographic question, unless perhaps one was particularly unusual or central to the analysis, just the essential design features. And linguistically, remember what we said about tense. In methods, it's almost all past tense. You're reporting what was done. The questionnaire was distributed, participants were asked, data were analyzed, completed actions in the past.
Okay, past tense, just the essential details. Now, what about that active versus passive voice thing again? You said passive is common, even preferred in methods. That still feels a bit counterintuitive, especially with grammar checkers always flagging passive voice.
It does feel counterintuitive sometimes, but it's a really strong convention in scientific and technical fields. Passive voice is often the default in methods sections. And the reason, again, is focus. Using the passive, the solution was heated to 50 degrees C, puts the focus on the action, heating, and the object, the solution, rather than the researcher, I heated the solution. In science, the process is often considered more important than who did it, especially for reproducibility. It creates that objective, impersonal tone. Think about that vaccine example from the source. The virus strains are identified and 3 are selected. Samples are injected. The focus is purely on the steps of the process.
Okay, focus on the process, not the person. But you mentioned a caveat about using by.
Right. Generally, in formal method sections, you want to avoid passive voice followed by a human agent. The samples were collected by the research assistant. It sounds a bit informal and shifts focus back to the person. Now, if you're talking history or theory, fine. The structure of DNA was discovered by Watson and Crick. That's different. But in methods, if you use by, it's more often with the process or a non-human agent. Analysis was performed by gas chromatography or heat loss occurred by convection. The instrument, or the physical process, is acting like the agent. For a class paper, maybe you'd include a by John if it helps clarify roles for your instructor, but in published work, it's less common in methods.
Got it. So be mindful of the focus. Now, if you're describing a sequence of steps, how do you make it flow well? Avoid just a choppy list of sentences.
Great question. Flow is important. First, try connecting verb phrases where it makes sense. Instead of, the mixture was stirred, then it was filtered. You can combine them smoothly. The mixture was stirred and filtered. Much cleaner. Connects related actions.
Simple but effective.
Second, use time adverbials generously. Words like first, next, then, subsequently, following this, after X minutes, finally. These are like signposts for the reader, guiding them clearly through the sequence. Don't be afraid to use them. Clarity is king here. First, A was done. Next, B was added. After 10 minutes, C was measured.
Like verbal breadcrumbs.
Exactly. And a third, slightly more sophisticated technique is using ed participles as adjectives. This really helps create that smooth, old-to-new information flow we talked about. So instead of, we selected the participants, we screened the participants, these screened participants completed the survey, which is repetitive. You can use the participle. The selected and screened participants then completed the survey. See how selected and screened now act like adjectives describing the participants? It links the actions performed on them directly to them, making the sentence more concise and elegant. It shows a characteristic they acquired through the process. The purified compound was analyzed, that kind of thing. Really improves cohesion.
Selected and screened participants. Purified compound. Yeah, I can see how that flows much better. It packs more information in smoothly. Okay, that's super helpful for methods. Precision, the right level of detail, careful voice choice, and flow. It's all about building that credibility, letting people see exactly what you did. Now let's shift to the payoff, the results section. This is where you share what you actually discovered, right? But first, you mentioned a crucial distinction people often miss. Data versus results. Can you unpack that again? It seems fundamental.
Absolutely fundamental. Getting this distinction wrong is a really common pitfall for new writers.
Yeah.
And it can seriously weaken a paper. Okay, think of it this way. Data is the raw stuff, the facts, the figures, the numbers you collected, the readings from your instrument, the answers to your survey questions, the measurements you took. Data usually lives in your tables and figures. It's the raw material, unprocessed, the spreadsheet columns, the points on the graph.
Okay, data, raw, facts, and figures.
Right. Results, on the other hand, are the statements you make in the text that summarize, interpret, or explain what that data shows. A result is the message derived from the data. It's the answer to, so what did you find? Is value X higher than value Y? Is there a statistically significant difference between group A and group B? Is there a trend? Is there a correlation? That's the result. The data in the table or figure supports the result statement you make in the text. Here's the aha moment. Novice writers often just point to a table, table 1 shows the data, and stop. They present the data, but they fail to actually state the result. They don't tell the reader what the key finding is in words. You have to actually write sentences like, Group A scored significantly higher than Group B, Table 1. That sentence is the result. Table 1 is the supporting data. You need to tell the story of the data, not just show the data itself.
Don't just show, tell what it means. That's a huge takeaway. So results are the narrative interpretation of the data presented in the text.
Precisely. And linguistically, as we noted, result sections tend to use past tense, reporting what was found, variable passive voice, maybe some hedging, and, surprisingly to some, variable amounts of commentary.
Whoa, hang on. Commentary and results. I thought results were supposed to be just the objective facts and all the interpretation commentary that's saved for the discussion section. Isn't that like rule number 1?
It is a very common belief, and it's a good rule of thumb in principle. You definitely save the major interpretation, the broad implications, the speculation, the what this means for the world stuff for the discussion. But reality is a bit more nuanced. Studies that actually analyze published papers, like that Thomson study of biochemistry papers mentioned in the source, find that scientists do weave commentary into their results sections.
Really? Like what kind of commentary?
Several kinds, actually. They might offer a brief interpretation right there to clarify a specific finding. They might justify why they presented data in a certain way, linking method to result. Very commonly, they'll point out how their finding agrees or disagrees with previous studies consistent with Smith 2020, we found. That comparison is a form of commentary, bolstering their finding. And they might even comment on the data itself, highlighting something particularly strong or unexpected or important within the data set. Notably, the difference was largest in Group C. That notably is commentary.
So it's not a free-for-all interpretation, but strategic comments focus tightly on the findings themselves.
Exactly. It's about guiding the reader's understanding of the results as they're presented. While big calls for future research are safe for the discussion, authors use these smaller rhetorical moves within results to subtly argue for the validity and importance of what they've found. It's persuasive, even in the facts section. The key is keeping it focused on the results, not drifting into broad speculation.
That's a really important clarification. Okay, so within the results text, besides stating the findings and maybe some focused commentary, you also need to point readers to your tables and figures. These location statements, how do those work best?
Right. Location statements are essential. See Table 1, as shown in Figure 2, etc. Their job is simple.
Yeah.
Direct the reader to the visual evidence. Experienced readers might scan the figures first anyway, but you still need these statements in the text. They're part of the meta-discourse, the language about the text that guides the reader and explicitly links your narrative claims to the supporting data visuals. It makes the connection formal and clear.
Are there standard ways to phrase them?
Yes, research shows a few common patterns, and knowing them gives you options depending on what you want to emphasize. Based on a study looking at civil engineering papers, here are 5 common ways. Pattern A, focus on the data. The high rates are shown in Table 3. Data is the subject. Pattern B, focus on the visual. Table 3 shows the high rates. Table is the subject. This was actually the most common in that engineering study, maybe because it highlights the visual itself. Pattern C, parenthetical, very common. The rates were high, see Table 3, quick and unobtrusive. Pattern D, subordinate clause at the end. The rates were high, as shown in Table 3, flows nicely after the main point. Pattern E, subordinate clause at the beginning. As shown in Table 3, the rates were high. Sets up the evidence first.
So different ways to phrase it depending on emphasis or flow. Pattern B, Table 3 shows, sounds quite direct.
It is, and it gives agency to the visual. But preferences vary by field. Sometimes putting the clause at the end, Pattern D, feels smoother. The key is to be consistent and clear, always making sure the reader knows exactly which visual supports which statement in your text.
Okay, clear signposting to visuals. Got it. Any other tricky language points specific to results sections?
One that often trips people up is subject-verb agreement when you're talking about proportions, fractions, or percentages. The rule is, The verb agrees with the noun in the off phrase, the thing being counted or measured, not with the proportion word itself.
Wait, say that again? The verb agrees with the noun after the proportion.
Exactly. So you'd say, a large proportion of the students are, because students is plural. You wouldn't say proportion is, or nearly 75% of the sample was, because sample is singular, not percent were, or 1/3 of the participants were, plural participants. 1/3 of the cake is, singular cake. The verb looks past the fraction or percentage to the actual noun to determine if it's singular or plural. It's a common slip-up.
Ah, okay, that makes sense. Focus on what's actually being divided up. Good tip. What about making comparisons? That must happen all the time in results.
Constantly. Results are very often about comparing groups, comparing conditions, comparing your findings to previous work. It's central to showing what's significant. You have your basic comparison. Group A performed better than Group B. Simple enough. But you can get much more sophisticated and precise. For instance, to avoid repeating nouns, use that of for singular or those of for plural, instead of the reaction time of the treatment group was faster than the reaction time of the control group. Ugh, clunky. Use the reaction time of the treatment group was faster than that of the control group. Much smoother.
That of those of good trick for conciseness.
Yeah. You can also precisely quantify differences. Don't just say higher than, say how much higher than. Group A score was more than 20% higher than that of Group B. Gives much more information. Or use multiplication comparisons. China produces 4 times as many engineers as the United States does. Or using times the noun of. This method requires twice the amount of solvent as the traditional method. Very precise. Also remember phrases like similar to, the same as, and especially compared with or compared to. The success rate was 80% in the experimental group, compared with only 50% in the control group. Now, using these more complex, more precise comparative structures allows you to really highlight the specific relationships and magnitudes in your findings. It adds a layer of sophistication beyond just simple greater than less than statements.
Wow, okay. So results isn't just about listing numbers. It's about crafting clear statements, linking them explicitly to data, using precise language for comparisons, maybe even adding focus commentary, and guiding the reader carefully. It's telling the story hidden in the numbers. So thinking about our listeners, what does this all mean for your writing? For how you approach reading, or maybe even starting to write these kinds of papers? We've covered a ton today, haven't we? We looked at how academic publications are actually pretty diverse. It's not just one kind of paper. We unpacked that standard IMRD structure, that hourglass shape, and then we really got into the nitty-gritty of methods and results sections. The details matter: verb tense, passive voice, how much info to give, how to present data versus results, how to make clear comparisons. It really drives home that writing a research paper well is this blend of being rigorous, scientifically sound, but also being a strategic communicator. You need both. Next time, we'll build on this foundation. We'll tackle the introduction and discussion sections in detail and look at crafting those all-important titles and abstracts that grab a reader's attention.
And maybe just leave you with a thought to chew on. Something that comes up a lot in academic discussions. It's precisely that line we touched on. How much interpretation, how much storytelling really belongs in the results section versus the discussion? Where does commentary cross the line from helpful clarification into premature interpretation? There isn't always a single hard and fast answer. It can depend on the field, the journal, the specific findings. So my challenge to you is this. As you read papers in your own field now, start paying conscious attention to this. How do authors handle that results section? How much commentary do they include? How do they use language tense, voice, comparison structures, location statements to guide you, to persuade you, even in what seems like the most objective part of the paper? Because really, knowledge isn't just about having facts. It's most valuable when it's understood and can be applied. So take these ideas, look for them in action, think about how you can use them to make your own reading more critical and your own writing more effective. You'll start to see the architecture of academic argument in a whole new way.
Được thành lập 2018 bởi nhóm giáo viên đã có nhiều năm công tác tại các trung tâm lớn uy tín ở thành phố Hồ Chí Minh. IELTS FOCUS không chỉ có các bạn học viên giỏi là các bạn tiến sĩ, bác sĩ, nghiên cứu sinh, các bạn học trường chuyên, mà còn có các bạn học sinh lớp thường đạt được điểm số IELTS và TOEIC cao nhờ vào phát triển được năng lực tiếng Anh thực thụ. Khác biệt với các trung tâm lớn, đông đúc, dùng chung một quyển giáo trình rập khuôn cho hàng ngàn học viên, lúc đi thi gây nhàm chán cho giám khảo chấm điểm. Đa số các chương trình online hay học trực tiếp tại thành phố Hồ Chí Minh của IELTS FOCUS chỉ tầm 3 đến 7 học viên, dễ dàng theo sát các bạn, giúp tối đa hóa điểm số nhờ tích hợp nhiều phương pháp trong suốt quá trình giảng dạy. 100% lớp học luyện đề được hướng dẫn bởi thầy Quốc Khánh, IELTS 8.5, Reading 9.0, Listening 9.0 và không có band điểm nào dưới 8. Các bạn có thể theo học tại quận 6, quận 2, quận 9 và quận 11. Nếu các bạn ở xa, có thể chọn hình thức học online. Giáo viên vẫn có thể theo sát được các bạn vì sĩ số lớp vừa phải.
Waves rolling in so slow. Trust the tide, let go. Ooh, yeah. Deep blue, take me home. Feel the calm in my soul. Stars above guide me right. Moonlight whispers through the night. Ocean